Hi everyone, this is Miss Graham. Today we are going to be continuing to look at algebraic methods of solving quadratic equations, and today we are going to focus on the quadratic formula. So we are looking at lesson 32-3, so go ahead and pull out pages 474 through 476. Our learning targets for today are to derive the quadratic formula, and we are also going to solve quadratic equations using the quadratic formula. Now, the past couple days, we've looked at two other ways on how to solve quadratic equations, such as solving by factoring, building off of our last fluency check, as well as solving by using the square root method. To start off this lesson, we're actually going to derive, meaning we're going to come up with the quadratic formula itself. So below, we're going to move step by step through different pieces. We're going to actually end up manipulating our general equation for a quadratic function into isolating x by itself to solve for what our zeros or x-intercepts are, where we're looking at and seeing, hey, our quadratic function is crossing our graph on the x-axis. So just a little bit of a preview of what we're going to be connecting it to. So let's go ahead and zoom in on our given quadratic equation. So we know right here, this is the general form where we have ax squared plus bx plus c. We've previously gone through how to factor this and then use the zero product property to set both of our binomials equal to 0 and solve for what x could be. Using our square root method, we're usually not given this middle term, so we're usually given just an x squared, possibly a number that we're adding or subtracting, maybe a number out front that we're multiplying, dividing, and being able to use the square root method for that. We're going to take a whole different approach today. So what we're first going to do when we're looking at this is our goal is to isolate x. Our goal is to get x by itself. So I'm going to say our goal is to get x by itself. So that's kind of what we're looking at here. Now let's start to look at how the textbook started to get x by itself. So let's look at it and see what it actually did to get to this next step. So take a look to see what happened and how each of the terms changed. Well, here we actually see two steps actually occurred. So the first step of what happened was we actually moved c over to the right side, because we can look at and know that c is going to be on the right side, and we know 0 minus c will be negative c. Now let's look at what happens next, okay? So we moved c to the other side, and now we see we don't have a coefficient in front of a anymore. So with our quadratic equation of ax squared plus bx equals negative c, what we did was we actually divided everything by a. If you can kind of start to see that, that's why we're dividing by a there, and we can see that it canceled out right here. So that was our next step. We divided by a. So we're just making a couple of notes here and there to just see what the textbook did. Remember, our goal is to get x by itself. So you're probably thinking, there's a lot of ways to approach this. Well, let's just keep working through what the textbook is doing. Now, the next part of what we're going to do is actually going to be a little bit complicated. Now, keep in mind that we have an equation here. We have this equal sign where there's something balanced on both sides of our equation. So we know if we added something to both sides, our equation will still hold true. Or if we subtracted something, if we multiplied both sides or divided both sides by something, we know the equation would hold true. A lot of the times what we're looking at doing in regards to adding, subtracting, multiplying, and dividing usually is to try to figure out how to get our variable by itself. So we're usually working with pieces that we already see here. Now, we're actually going to add something in our equation that is not something that we see here. If you look at what we have in this equation, and what we move down here, you're probably looking at this and seeing, wait a minute, we added b divided by 2a squared to both sides. Where did that come from, right? We have no idea where that came from. That's a little bit confusing. So I'm going to walk you through a side example to better understand where this came from and why we added it to both sides. Let's think back to when we factored before, all right? So remember when we had a trinomial, let's say we had x squared plus 10x plus 25. We had these special equations where there was some type of pattern that we noticed. So let's say we went through the work, what multiplies to 25 adds to 10. Let's say we went through and factored it. What we would end up getting as a result is x plus 5 times x plus 5. Or we could write that as x plus 5, that whole quantity squared. This idea is what we're trying to create down here. We're trying to notice and see, hey, is there a pattern between this 10 and this 25 that yields that 5 in both of those binomials, so that 5 is the same piece. So that's what we're looking at here. Both of these two terms, the x plus 5, they play an important role here and here. Let's say we labeled our x and our 5 with just very generic letters, a and b. So we have some a plus b quantity squared. What we're going to realize is if we always have that same binomial squared, we will end up with a pattern of 2 times a times b as our middle term. Our first term will always be a squared, and our last term will always be b squared. And we're going to be adding those together, specifically when we have an addition sign there. So this side example is going to help us realize why we're adding this to each side. So think about this. We have to figure out what the a and the b are in our middle term and figure out, okay, we want that b squared. Now we have to look at what our a squared is to figure out here. So here we know we have x squared, so x is really our a value. Now we have this middle term, right? We want to take out that x because we just want the number, and we also want to divide this by 2. So essentially, we're looking at b over a, and we want to divide it by 2. Now keep in mind that when we divide by a number, that's the same thing as multiplying, let's try again, same as multiplying by the reciprocal. So we know when we multiply those, we get b over 2a. That's what we're looking at. And hey, if you can tell, that's exactly what we have right there. Right? We can see that's what we have inside here. And remember, we want our b, right? We want our b squared, so that's why we squared it. So our goal is to figure out how to create a trinomial and rewrite it as a binomial squared, so the same binomial. So that's kind of our goal right here. We're figuring out how to add this to both sides. So we're going to go ahead and add b over 2a squared to both sides. So we add b over 2a squared to both sides. Again, I know that this is a little bit of a higher order problem. You're probably thinking, oh my gosh, this is a little complicated, but no worries, right? It's okay to be getting a little confused here because remember, our overall goal is to get x by itself, and the book's kind of guiding us through how to do this. This is something that deriving equations is something that a lot of higher math classes do. So you as a mathematician are doing a great job keeping up with this. So remember, we're going to keep going, uncovering what the book is telling us to do, and seeing if we can figure out how we can get x by itself. So using what we wrote down before, remember, we're trying to get some binomial squared. Noticing the patterns of what we have here, that's how we're going to get to this next step. So our goal is to rewrite this side in regards of a binomial. So let me go ahead and pick a different color to work with. So our goal, remember, is to have a binomial squared. Just like we worked with this trinomial, getting to that binomial squared. So we're going to have the right-hand side of our equation. I was almost thinking, I was like, you know what, we should keep it the same. But I'm almost thinking maybe we should kind of multiply some of this out. Like we could multiply this out, right? So we have negative c over a. And we're going to be adding, it's multiplying b over 2a times b over 2a. So we're going to figure out kind of how to work through that, maybe rewrite what we have. So this idea, we could multiply this together, right? So on top, we're going to get b squared. And on the bottom, we're going to get 4a squared. So maybe I could rewrite that as that. So on the top, we will have b squared, and on the bottom as 4a squared. Now, it's kind of hard on both sides here. You know, if we're adding fractions, we really want our denominators to be the same. Now, we're almost right there. We see there's an a on the bottom of both, but, you know, it'd be nice if this had a 4 and then an a squared on the bottom. So maybe what we could do is multiply our top and bottom by 4a, because that's the additional piece we need. So on top, we can put 4a, and on the bottom, when we multiply a times a, we get a squared. So we can see our overall goal at the end is probably to add these two together in some way. Now, something that you want to keep in mind is, remember, there was a negative out front in front of, you know, our c divided by a originally, so don't forget the negative right out here. Now going back to what we had before, let's see if we can find our pattern. We know our first term is going to just be x since we start with x squared, so let's fill that in here. And then we want to figure out what this this end term is. We're going to be adding since everything is still positive here, so we can go ahead and put an addition sign. And what we're going to be adding in this spot is actually going to be this term itself of what's getting squared. Because remember, we just want our b value here, and this represents b squared. So we're going to add b over 2a inside of here. So b over 2a. Again, I know this is starting to look a little bit complicated, but no worries. We're going to start bringing it all together. Now, eventually, you can see if we start to look from here to here, that our squared sign goes away, and we have a square root on the other side. Most likely, we're going to have to do that. We're going to have to take the square root of both sides. But something I want to re-emphasize before that is kind of putting all of this together on the right side. We can actually rewrite that, keep in mind, as everything divided by 4a squared. And when we add these two together, we're going to get negative 4ac plus b squared. Now, since this is a negative term, we could actually flip-flop and rewrite it as b squared plus a negative 4ac. And that's exactly what we did down here. So just kind of reminding you of that. So our steps, we added b over 2a squared to both sides, and we rewrote the left side as a binomial squared, and the right side we kind of worked on having a common denominator. So our next step was, let's try again. We turned the left side into a binomial squared, and we found a common denominator for the right side. Again, remember, our ultimate goal, if we go back up here, is to work on getting x by itself, and we're manipulating our equation to do that. So remember, our goal now is to take the square root of both sides. So let's go ahead. We're going to take the square root of both sides, just like that. Square root of both sides. So we take square root of both sides. So look at what we have now. We're just going to have x plus b over 2a. And remember, when we take the square root, going back to solving by square roots, remember, we can have a positive and negative result. We're familiar with that sign. And we take the square root over this whole entire piece. Now, the cool thing is, we're almost on the way to getting x by itself. Let's try to simplify this a little bit here. So let me go ahead, try to rewrite this as the square root of b squared minus 4ac. And I'm going to put it over the square root of 4a squared. Now, if we think about this, we can actually break up the square root of 4a squared. We can rewrite that as 2a. So think about this. We're rewriting this as 2a. We're going to keep this on top. And remember, we have the plus or minus out front, so we could rewrite it as plus or minus the square root of b squared minus 4ac, and that is over 2a. Now, something that actually happens, right? So maybe what we could do is we could just rewrite the denominator here, right? I could just rewrite that as 2a. So let's go ahead and do that. Let's rewrite that as 2a. All right. So we're going to cross that out, put just 2a. Now, also think about how not just, simplifying what's on the right side, but what we can also do is we can start to move over our b over 2a. We can move that to the right side as well. So that'll kind of be like a second step to this. So we're going to simplify the right side, and then what we'll do is we will subtract b over 2a to both sides. b over 2a, so we're going to subtract b over 2a. Now, getting a little bit complicated over here. Let's rewrite what we have. So we're going to rewrite, we have x on the left. On the right side, we have negative b over 2a. I can actually put that up front if I want to. I could put it and reverse the other spot, and then I'm having plus or minus the square root of b squared minus 4ac. That is also over 2a. So we are rewriting what we have kind of as that next step. And then looking at this, they both have the same denominator. So what we could do is we could put both, the negative b and the plus or minus the square root of b squared minus 4a. Oop, I forgot the c. 4ac. And again, we can put them both over 2a. So looking at this, that's what we're rewriting here. So let's just think out to what we were originally at. Our goal was to get x by itself. We figured out how to rearrange a generic quadratic equation to come up and isolate x by itself. These letters of b, a, and c, they all represent the coefficients in front of our x squared, our x, and our constant. So what we're going to learn is if we have a quadratic equation, we can take those coefficients, plug them into this formula right here, and we will get those x-intercepts or those roots, looking for our solutions. So that's exactly what we're looking for here. Again, if we go down to the bottom, we just went through how to prove and find the quadratic formula. We derived it. We came up with it. And I know it was a little bit hard, but you did a great job doing it. So keep in mind, right, the solutions of ax squared plus bx plus c equals 0, we can use this formula, this quadratic formula, where we have to make sure that at least the a value is not 0. That means we have to have at least an x squared in our equation. So let's go ahead to the next page and we're going to see how we can apply this quadratic formula to find our solutions. So on the next page, it says to apply the quadratic formula, make sure the equation is in standard form. So it has to be x squared plus our x value plus our c. We identify the a, b, and c values in our equation, just like we would with factoring, but then we're going to substitute these values into that quadratic formula. So we're also going to learn about how, if our expression, if the part that we're looking at is the radical sign, and the number underneath that radical sign is not a perfect square, what we're going to have to do is really throw back to simplifying radicals. We're going to have to write the solution in simplest radical form, but we're also going to practice using a calculator to approximate the solutions as well. So let's go ahead. We're going to start looking at an example from the textbook, and we're going to practice looking at it together and then practice some of our own. So it says we want to solve this equation right here using the quadratic formula. So the first step it tells us to do is to write the equation in standard form, meaning we want all the terms on the same side. So we can see here we end up subtracting x from both sides. So if you want to show that work, you can. So you can subtract x, and then we're left with x squared minus 6x plus 3. Now, you're probably thinking, well, what if I wanted to use factoring, or what if I wanted to solve by square roots? The quadratic formula is for problems where we really have a tough time factoring or using square roots. Now, factoring, we would probably figure out what multiplies a 3 adds to -6. You're probably thinking, there's no number combination. There isn't here. So we can't really factor it. You also see that there's a middle term here, right? So we really can't take the square root and do the square root method. So a lot of the times the quadratic formula, it's used on those really tough problems that we can't factor or we can't use solving by square roots. But here's the cool thing. You can use the quadratic formula on any quadratic equation. So we'll start off showing how to use it on this one, and then from there we'll practice on some others. So we want to identify a, b, and c, so we go ahead and do that. Our a value is 1, our b value is -6, and our c value is 3. Then after that, we substitute a, b, and c into our quadratic formula. So I'm actually going to write down the quadratic formula in the space below here so we can just remind ourselves of it. So it's going to be x equals the opposite of b, or -b, plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's say we want to know some patterns. We're going to put 1 in for our a spot. We're going to put b as -6 in for our b spot. And then we also have our c value of 3. We're going to put that into the c spot. So look in here. When we say we want a -b, we want the opposite sign of -6. So really it's going to change into a +6. So the opposite of a negative is our positive. We have plus or minus the square root of our b value squared. Now, keep in mind, you want to put parentheses around that, especially if it's a negative, right? Because it's -6 times -6. We know that's a positive 36. Then we're subtracting these 3 numbers multiplied. Remember, we can multiply in any order of those 3 numbers, doesn't matter, but we will end up getting 12, so we're subtracting 12. All of that is under our square root. And then on the bottom, we have 2 times a, which is 2 times 1. Now, when we're simplifying this, as we kind of started talking through this, we definitely want to make sure that we're multiplying underneath here first, and we're squaring first before we do our subtraction. So that's why I rewrote 36 minus 12. That gives us the square root of 24. So we really have 6 plus or minus the square root of 24 over 2. Now, we can write this as 2 solutions, totally fine. Something I do want to talk about eventually is simplifying kind of our radical. It gives a little bit of a hint down here to how we're going to do that. So what I'm going to do is I'm going to kind of jump down to here to show you what's going to happen. So the square root of 24, we can actually break down. So let's look at 24. We can break that down into 4 times 6. Remember, both are under the radical, so following our radical rules, we can take the square root of 4 times 6. Now, remember, we can also give each one of those numbers its own radical, right? We have the square root of 4 times the square root of 6. Now, we know we can take the square root of 4. That's 2. We can't take the square root of 6 because that's only 2 times 3, so we keep that the same. So that's how we're looking at, and we have 2 square root of 6. Now, here's another way that we could also process what's going on. Remember, we have 2 numbers on top here and 2 numbers on the bottom. They're both being divided by 2. What's really nice is that they're both even numbers. So we essentially could do 6 divided by 2 as well as 2 divided by 2. The way that they represent that is they pull out a common factor of 2, a greatest common factor out of both of these terms, right? As long as it's outside a radical. So that way we can do 2 divided by 2. That reduces, so we're left with 6 plus square root of 6. But you could also do it this way. We could divide 6 by 2 to get 3, and when we divide 2 by 2, we get 1. So remember, we can write square root of 6 as 1 square root of 6, so that's how we get our answer here. So really, we want to use this form. I would rather have us reduce the radical, use this form up here. So the textbook really didn't show you that, but I'm going to really encourage it. So we want to break down and write 3. Let's try that again. We're going to write 3 plus or minus the square root of 6. Now remember that plus or minus stands for we're adding and subtracting. So there are going to be 2 solutions here, right? So we got to remind ourselves of that. So let me try again. We're going to have 2 solutions. So we're going to focus on putting this in our calculator. So the 2 solutions will be 3 plus the square root of 6, and we're also going to have 3 minus the square root of 6. So remember, when you're putting these in your calculator, I'm going to recommend that you put the whole number in front. You can put the square rooted number in front first, but a lot of the times it will need a set of parentheses around it, so it can be a little complicated, but I would encourage you putting the whole number in front. Now remember, we're going to have an addition version as well as a subtraction version. So let's go ahead, pull out your calculator. I want you to try typing these 2 in, and let's see if you can remember how to round to the nearest hundredth. That's 2 decimal places. So go ahead, pause the video and press play when you're ready to check your answers. All right, let's go ahead and check. So for 3 plus the square root of 6, we should get 5.45 when we round. And for 3 minus the square root of 6, we should get 0.55. So make sure you're practicing on rounding and are familiar with how to do that. So I know I've kind of hands-held you a little bit as we're going through deriving the formula, practicing how we can go through and find out what our solutions are, right? What our x values are, especially if they're decimals. So we're going to go ahead and try practicing A and B together, walking us through how we can solve these. And then on the next page, I'm going to have you try a couple on your own. So let's look at part A. Solve using the quadratic formula. So let's start off looking at what we need to do. Well, we probably need to bring all terms to the same side. So I like bringing them to the left side. So I'm going to subtract 4x and subtract 3. I'm going to do it at the same time just because of the space. So we have 3x squared minus 4x minus 3 equals 0. All right, so my next step is probably to label my A, B, and C, because I'm going to be plugging those into the quadratic formula. So let's practice writing the quadratic formula. So it's going to be x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. So for part A, we're going to plug in 3 for A, -4 for B, and -3 for C. So what we're going to have is the opposite of -4, so that's a +4. Plus or minus the square root of b squared, so that's -4 squared, minus 4 times a, which is 1, times c, which is -3. Everything is over 2 times 3. Oops, I also just realized I accidentally plugged in 1 for my a value. I was going off of the last problem, so make sure you change that to a 3. So let's keep working on this. So we have 4 plus or minus Let's simplify that -4 squared. That will be 16. So remember, you have parentheses around that when you square it, even when it's a negative. And then when we multiply these numbers together, it's really, we have a -12 times a -3. So in this case, we are going to be adding 36. If you need to break it up into more steps, you can, but I figured we can move a little bit quicker since we're familiar with this. And everything is divided by 6. That's 2 times 3. So now we essentially have 4 plus or minus. Well, we're going to do 16 plus 36. So when we add those two together, we end up getting the square root of 52. A little bit ugly of a number, but don't worry. We're going to see if we can work with it. So on the bottom, we're dividing by 6. Now, let's start thinking about, okay, what multiplies into 52? Well, we know it's an even number, so we can at least multiply by 2. Sorry, we can divide by 2. So if we do 52 divided by 2, that's actually 26. So we know 26 is an even number. So technically, I mean, we could divide it by 2 again. Wait a minute, that probably means we could divide 52 by 4, right? That's the biggest perfect square number that it goes into. So I could rewrite my square root of 52. I could rewrite it as the square root of 4 times the square root of 13, which we know the square root of 4, right? Square root of 4 is just going to be a big old number 2. So rewriting this, we have 4 plus or minus 2 square root of 13 over 6. Keep in mind that we have 4, 6, and 2. They're all even numbers there. We can divide 4 by 6 as well as 2 by 6. We can reduce those fractions. What we're really doing here, and I'll show you what we're looking at, is we're giving both of these terms a denominator of 6. I know it didn't show it on the last problem, but I'd love to show it here. So we really have 4, 6 plus or minus 2 square root of 3 over 6. So that's how we're able to reduce this 4, 6. We're able to reduce that to 2 over 3. And we can add / subtract it from, well, let's reduce 2 over 6, right? That's going to be 1 square root of 13 over 3. So both of them have a denominator 3. We can put those two together. So that's how we're able to get, let's try it again. That's how we're able to get 2 plus or minus the square root of 13 over 3. And that is going to be our exact result. So that's really us before we were putting that into a calculator, testing it out, figuring out what the decimals are. That's our exact form. So now let's practice using a calculator. So this is our exact answer. So let's figure out our decimal answer. And we are going to practice rounding to nearest hundredth. So we want 2 decimal places. So we're going to try that. So that means we have to do 2 plus the square root of 13 over 3. And we also have to do 2 minus the square root of 13 over 3. Now, a lot of the times when I do this, and I'm going to give you a heads up when we're plugging this into our calculator, is I really want to make sure I have my parentheses. A lot of the times I will just put this into my calculator, figure out what that decimal is, and then I click the divided by sign, and that'll take my previous answer that I got, what I got, the decimal here, and divide it by 3. I could do the same here and just divide it by 3. But if you want to figure out how to put this all together in your calculator, I'm going to show you how. So I want you to first start off by putting a parenthesis, because we want to put parentheses around this whole piece here. Now, something else that definitely pops up is there's a parenthesis that comes into play there. So we really want to type this into our calculator. So you have a parenthesis. We're going to click 2. You can click plus. Then we're going to hit the second squared sign, so our square root pops up, and what will automatically happen is there is a parenthesis there as well. We're going to go ahead and type in 1, 3, and then close our parenthesis. Then we're going to add another parenthesis to signify, hey, we want you to do this addition on top first. And then we're going to divide, so click the divide by sign, and then you can click 3. So go ahead, test that in your calculator. Let's see what you get. All right, I put it in my calculator. Now remember, I'm going to use kind of these squiggle equal signs to mean that we rounded, because technically we are rounding. Let's round it to nearest hundredth. That means 2 decimal places. So let's look at our decimal number. You probably got something like this. So if we want 2 decimal places here, we look at our third number, and if it's 5 or more, that means our second number rounds up. So because this is 5 or more, this will change into a 7. So let's go ahead and change that into a 7. So that way we have 1.78 as our answer. I want you to now try doing the same thing here, but now you're going to do with a subtraction sign. So type it on in, see what you get, pause the video, and come back when you got your results. So an interesting result is we actually get a negative this time. It is very possible to get negative numbers, right? It's possible to get negative x values as solutions. So we got a negative 0 point, and if we look at this, we get 535. So since this third result is a 5 or more, that means the 3 rounds up to a 4. So we're going to have for our answer negative 0.54. Now keep in mind when we're rounding, it will either stay at the exact same number or round up. It will never round down, so something to keep in mind. All right, so look at that. We were able to come up with results where we could see, okay, what's happening, what's going on when we solve and have an x value. Looking great. Now, I want you to go ahead and test out part B on your own. I want you to test out, do all of this work. I'm going to do my work over here, pause the video, and then we can come back together and go over our answers. All right, let's go ahead and check your work and your answers. So I rewrote my quadratic equation. I plugged in my a, b, and c value after I put it into standard form. I have my exact answers here, and I have my decimal results as well. I will tell you the answer on the left is from when I added. The answer on the right is from when I subtracted. So if you do have questions or concerns, feel free to look over this to see my work. Now, depending on who your teacher is, you may have homework on the next page, or you may have homework as a different assignment to practice using the quadratic equation. But go ahead and check in with your teacher to see what that is. For Miss Graham students, we are going to go ahead and turn to the next page, 476, to see what our homework assignment is. All right, Miss Graham's class, for homework tonight, we are looking at page 476, and you are going to be looking at numbers 1 and 2. Solve using the quadratic formula, so you can look back at what we did today for examples if you need a little bit of help. Now, I want you to have exact and decimal answers. So exact means before you put it in the calculator, and the decimal answers is after you put it in the calculator. I'm actually going to have you round to 2 places. That means 2 places after our decimal. The technical word for that is hundredths. So Miss Graham's class, go ahead. You can get started on tonight's homework, and happy mathing.